Welcome to Bankable. I'm Doreen Abisundra, your host and a proponent of innovative technology and financing solutions for AI infrastructure, decarbonization, and energy security.
Nuclear is going to be the future, be it whether in Singapore or the rest of Southeast Asia. We are here to be a verifier as a third party for companies that need a third party. And as you say, due diligence, okay, it's been done, it looks good. That's all that needs to be said.
Welcome to our conversation with an engineering consultancy firm. I'm going to let our speaker explain what that means, what he does, and how this applies to the nuclear industry. Welcome, Matthew, to the conversation. Lovely to have you here. Now, let's start by telling us a little bit about who you are.
Thank you, Doreen, for having me on your podcast. Let me do a brief introduction about myself. My name is Matthew. I am a digital twin system architect and a nuclear competency and strategy lead with a company in Singapore called HYMNE Consultancy Services. My history is a bit of an exciting and interesting background, I would say. I'm trained as a nuclear engineer and probably one of the few nuclear engineers in Singapore. I know the number's growing, but it's definitely still a very small group compared to other people. And I studied and graduated in Singapore's NUS Engineering Science program, where I also then continued on to a Master's by Research in NUS before working with the Singapore government in the Chemical and Biological Radiological Nuclear Detection Center of Excellence. Well, bit of a mouthful, of course, but that's basically what I did, where I was actually on the team that did X-ray imaging and radiation-based imaging. So nuclear has definitely been part of my life. And then after I finished that stint, I studied at MIT in the Leader for Global Operations program as the first Singaporean in the program, actually, where I graduated with an MBA and a Master's in Nuclear Engineering at the same time. So that's a bit of my history. If for those that have observed, you notice a lot of my background is in nuclear. That is because that is something I've always wanted to do. I've actually known I wanted to do nuclear engineering since I was 16, 17, actually, around that age. It's been a bit of an obsession at this point. But yeah, I knew that was the path I wanted, and you can see it in my journey up to this point.
Brilliant. I'm actually quite curious as to how a 16-year-old Matthew got involved or interested in nuclear, given that nuclear really hasn't played that much of a role in Southeast Asia. So tell us more, what inspired you there?
What inspired me was competition in school. And what I mean by that is I had a classmate in my secondary school days. He's a friend, but it was a bit of a one-way rivalry. I'm someone who likes physics and science, so I've always wanted to be the best at it. And then I had a classmate who kept beating me. And that was around 15 years old. For those that are curious, don't ask. I'm just the kind of person. And then he tells me one day, I want to go to MIT because that's my dream school. So I'm at 15 going, I have no idea what school that is, but I want to go there to make sure I can find a way to beat you. So I go read the website, cool school. And then around the same time, I was reading the book about angels and demons, where Dan Brown talks about antimatter, matter annihilation, free energy from particles. And around the same time, I came across the MIT nuclear department page. And so I was reading it, I was like, hey, this is almost, okay, I know now people will be maybe saying it's different, but at that point, it looks similar, right? Like, oh, this is the same concept. So I got involved in it. And as they say, the rest is history. I went down that rabbit hole. Yep.
Brilliant. Fantastic. Yeah. That's really inspiring, actually. It gives us an insight into how reading, how a little bit of competition can inspire a new generation of what we are desperately needing now, professionals and people with competence in the nuclear industry. Fantastic. Thank you for that. Now, let's move on to what you're doing right now for work. Tell us a little bit about the two names that we see on the background in your screen here, HY and Beacon. Tell us exactly what those companies do.
Happy to do so. So HY is the company that's in Singapore that I'm working with. The full name is HYMNE Consultancy Services Private Limited. Bit of a mouthful, so we kind of shortened it down to just call it HY. So HY is quite an interesting company. I met them last year before I joined. That was the first time I heard of them. But it's a company that is actually rooted in Singapore's engineering development history. The company is 44 years old as of this year. And as I had learned, the founder of the company, Mr. Ho, is actually quite a legend in the electrical engineering field. In fact, as I understand it, his for those that are familiar with the professional engineers board in Singapore, he's literally one of the first professional engineers in Singapore. He has a single-digit registry number, and he was among the professional engineers who helped certify the Singapore power grid when it was being built in the 80s, and also the north-south and east-west line substations. All those were certified and commissioned by him. So the company has a very strong root in Singapore's engineering development over the years. And then now the son, Mr. Ho Si Fong, has taken over from his dad. And he is very much into trying to build this sustainability focus and the future of the company, evolving from your traditional mechanical and electrical consulting. To that end, he formed a daughter group called Beacon, what is known as Building Energy Efficiency Consultancy, which focuses a lot on the sustainability aspects of the work. And so this was formed about 3 or 4 years ago. And so I joined the company last year under the Beacon banner, but I'm also part of HY. And so my work in HY and Beacon largely focuses on taking charge of the digital twin portfolio, meaning we use digital twins for sustainability, building new capabilities in digital twin for various areas that HY is performing. And also I have another title, which is the Nuclear Competency and Strategy Lead, because our managing director, Mr. Ho Si Fong, when I met him, we had a very long 2-hour chat. And he basically said, you're right, nuclear is going to be the future, be it whether in Singapore or the rest of Southeast Asia. Even if Singapore doesn't do it officially, Southeast Asia will go nuclear. So he said, why not? We build some capabilities in it. And he actually apparently was looking at it for some time. He just had no idea how. So when I joined the company, we started formulating to see ways to engage in this nuclear industry. And of course, as any good business decision is made, you go with what you have. So you start by looking at what the company currently has and how those capabilities can be applied to the nuclear industry, meaning you take your traditional M&E consulting, high voltage design, digital twins, building design, how all that can be translated to the nuclear industry as usable skills.
Got it. And before we expand into those skill sets, maybe start with the first of the two components, the digital twin angle. Tell us a little bit, maybe firstly, even for the benefit of the audience, what you mean by digital twin, and give us an example of how you've used a digital twin.
That's actually a very, very important question, Doreen. I would say that many people in the industry probably heard the term, but unlike physics, there's no set definition. So what people need to understand is that there is only one thing that ties any digital twin conversation together, is that a digital twin is a virtual replication of that application. That's it. After that, the definitions change. So depending on who you talk to, which industry you talk to, and what it's used for, a digital twin changes completely. So in HY's case, the digital twin we currently use is basically defined as a virtual 3D model of the building that takes into account energy consumption, energy generation, and then we use this 3D model made and using physics-based modeling to find ways for your building to save energy. Now, the physics-based modeling is very important because most other simulations typically go by rules-based or assumptions. Here is the boundary condition, here's the starting condition. No, you're supposed to use physics models, like basically how very academic simulations do, but except in faster time for the industry. And then after that, when we run all these models, we find ways for your building to save energy. We find areas of inefficiencies here. We find areas that you can save energy there. And then we recommend, using this simulation, this digital twin, we recommend changes to the building to the client. And then we tell them, maybe you can save energy by just raising the temperature from 23 to 25. And that saves you 2%. Or maybe through the digital twin, we identify, hey, these various air handling units are a bit inefficient compared to the specs they're supposed to be running. So you need to change them. And then after that, after we make these recommendations, we can do two things. One is we give them this static digital twin that we've made for them to use for their own analysis, what if analysis. Maybe some vendor comes along and says, hey, I have this next generation air handling unit. We want you to buy it. they now have a virtual platform to actually test it out to make sure that it does give them the savings that has been promised before they put in the capital. And then the second thing is what we call the dynamic digital twin, where we deploy it in real time. And in real time, what it does is that it takes in readings in real time from all sorts of IoT sensors, your building management system, and it runs a simulation in the back end. And then the simulation will make predictions about what it's supposed to do and automatically feed back to the controls and say, make changes now based on what's coming. And what's very important is that in the case of Singapore, especially in the case of Singapore, because we have a very humid environment that's raining randomly, the physics model takes all this into account. How much humidity is coming in? What's the weather going to be like to simulate what changes to be made? And that is how you maintain the building's efficiency at the highest possible level it can be. So that's what we do.
Absolutely incredible. Wow. So it's not just predicting that I need to get a brolly out to head out, but also how that's going to transform the needs of a building. Fantastic. And now over to the nuclear angle. So I think you're being humble by not addressing the fact that you're the one that's really shaping and driving the conversation for nuclear within the company. So tell us more about what you're doing for nuclear with HY and Beacon.
Oh, for sure, definitely. So I would say that the first key thing, as I mentioned, we take a look at what capabilities the company has. So of course, digital twin being my primary portfolio is something we look at. So we are looking down, there are plans. I can't share details at this current time, but what I can do share is that we have highlighted that, and the industry themselves have highlighted that digital twins in the nuclear industry is a key capability that most future reactors and advanced reactors need for many reasons. And it could be for verification, it could be for license application, it could be for design testing, you name it, there's a need for it. And so the company is looking at seeing how we can translate our knowledge in digital twins that we currently have into this field and build capabilities around it. That unfortunately, because the digital twins in nuclear is still so nascent, there's also a lot of it will take time to build long-term capabilities, but it's something we've already highlighted and we're looking at slowly. Other areas that we are looking at in the company, example in HY, we do energy transition or microgrids. So basically, how do you design a microgrid for a client that wants to integrate solar or integrate a battery storage?
So Matthew, tell us more about what HY and Beacon do within the scope of technical consultancy and engineering.
Okay, for sure. So HY does quite a range of capabilities. Actually, HY and Beacon both do a wide range of capabilities regarding what we call the smart energy ecosystem of the future. So Beacon, focusing on the building side, we can define it as managing the demand, digital twins to increase your building's energy efficiency, therefore lowering the demand and optimizing your demand, and providing a platform for predictive load analysis, meaning that you know how much load is coming. And then on the other side, HY, we have your traditional M&E consultants who go and design more efficient HVAC, ACMV systems, basically your aircon systems, make it more efficient. But also we have other people who do high voltage consulting in the company. So basically they help design more efficient substations or more efficient layout of the electrical network. And that leads to the final area that we look at very broadly is microgrids. Microgrids are basically a very interesting approach to a grid. So we are all familiar with the power grid of the country. A microgrid is a very small grid for that particular application. So it could be for a building, it could be for a resort. And then the microgrid takes into account connection power from the grid, battery storage, solar, and other sources. And basically it optimizes how the energy is supposed to flow. And another thing that I learned from the company when I joined was apparently if you actually connect a generator to the microgrid and you don't connect it properly, if there's too much solar, it turns the generator into a motor because the electricity flows into the generator and reverses. So it actually spoils the equipment. So actually designing a microgrid with this many components and knowing how the energy dynamically flows is very important, right? So that is what HY, so you could say that HY then optimizes the supply of the ecosystem. And then both ends are being done to try and green your building or green the application. So one lowers your carbon footprint by trying to reduce your consumption. One increases your footprint of green energy to overall reduce the carbon footprint. And so that's broadly what HY does, among other small other services, which we can talk about as the conversation goes.
Fantastic. I wanted to expand into the conversation on microgrid in particular, just because we are starting to see it more across the globe. Yeah. So maybe give us an example of how a microgrid can be applicable for example, a data center or a nuclear power plant within the context of what you do.
Happy to do so. In fact, we just had a conversation on that point actually a few days back with someone else. So in the context of a data center, a microgrid becomes very relevant in the way they operate, right? With AI becoming the backbone of almost 99% of the processors on the planet, I would argue in time, it would become a critical infrastructure. So once you term something a critical infrastructure because it's so tied into application, your availability for data centers need to go from 99.99% to possibly 99.9999%. And in order to do that, you need to have battery storage on site, possible generators. I mean, companies are now talking about nuclear microreactors behind the meter at the data center. All this comes into this picture, but the question, you see, unlike people of us at home where we can just take a power socket and plug it in and say, okay, we're done. When you talk about connecting all these various systems to the data center in a smart manner, it's actually a microgrid because you need to put controls in place. For example, the battery storage needs to be charged. Are you charging it from the solar panel? Are you charging it from the grid? Are you charging it from this microreactor you put on site? No one knows. So you need all these smart systems. So once you start putting all these smart controllers into play, this becomes a microgrid. And for a data center, this is important because if you want to hit 5 nines of availability, let's just say in a very worst case scenario, the grid goes down, you have no time to react. Your backup must kick in almost instantly, right? You can't say to the grid, to the power data center, give me 1 minute, the generator's starting up. It must switch almost instantaneously. And so that's when a microgrid becomes very relevant to your data center, right? And so that's why we had a conversation with a data center operator the other day. They all were like, oh, let's just do a PPA. And I'm like, yeah, you can do a PPA, but your solar farm or your nuclear reactor, wherever is 10 kilometers away, if that grid goes down, your grid goes down, you still need something on site. You can choose not to put the solar farm or the reactor on site, but you still need some form of battery storage, which means you still need a microgrid. In the case of a nuclear reactor, it's a bit of a more interesting conversation. So in the context of Singapore, Singapore is used to 100% dispatchable grid, meaning that if the demand goes down, they can just turn off the power supply. If they need more, they turn on the gas turbine, and it starts ramping up again. It's easily controllable based on the demand. For a case of a nuclear reactor, for many of us that know it, other than the French designs in EDF, most nuclear reactors are constant output, meaning that once you start, the output is the same till you actually go down for refueling. And that is very important because in the context of Singapore, for example, if the country has never dealt with constant baseload energy, the question is, what do you do with all that energy in times of low periods, like at night, right? You can't just tell the grid, keep taking it, don't worry, you'll be fine. No, the energy must go somewhere. So you actually need to start integrating battery storage or usable load around this nuclear power plant or on the grid. And once again, we now have a nuclear microgrid, a microgrid powered by nuclear that also connects to the grid at the same time. So, and in a way, the nuclear microgrid gives a buffer to the main grid. Let's say, for example, there's too much energy in the grid, the microgrid can take over to take some of the energy away so it doesn't destabilize the grid. And at the same time, if the grid goes down, the nuclear power plant is not affected, will try not to be affected by the grid going down and can still power something. So it gives a level of protection because I don't think anyone on earth wants to hear the phrase, oops, something happened to the grid and the power plant's now affected, especially if it's a nuclear power plant. So you want to add that buffer in between, right? We all know the stories of Chernobyl and Fukushima. We don't really need a fourth in this case already. So that buffer is very important to protect the nuclear power plant in case the grid goes down, in case something happens to the grid.
Fantastic. Yeah. Really, really insightful there. So, and presumably you'd be using artificial intelligence to help you with managing the microgrids as well?
For sure. Definitely that's one option. What we try to do in HY is that before we try to start recommending AI or any other form of intelligence, we actually say, let's get the basics right. What is your load profile? How you want to design it? Only after that can we start putting in things like energy management systems, digital twins for microgrid operation, which I'm leading the development of in the company as a service we can provide. The digital twin for microgrid operation doesn't just take into account energy management, but takes into account weather as well. If you are using solar farms, will there be a cloud cover that's predicted? That kind of thing to do prediction. And it becomes a way for the digital twin on the microgrid to interact with the digital twin from the building. So the building digital twin can tell you how much I'm expecting. Then the digital twin on the microgrid side can start preparing ahead of time, right? So that it reduces the lag factor as well. So this is the kind of ways that you could use artificial intelligence or some digital smarts. But at the same time, as a caution, as a consultant, we always tell people that don't go to AI just yet. Get the basics right, and then AI on top of it integrated later.
Fundamental. So you're starting with human intelligence first, and then incorporating that which is artificial thereafter.
Exactly.
Brilliant. Really helpful to hear that.
Yes.
Tell us more about the other engineering consultancy activities that you do and why they are necessary in building out, whether it's a solar farm or a nuclear plant or a data center. What are these effectively technical knowledge that is needed?
So if I were to break down the question, I would say your first part is basically what other services does HY do and how does it all encompass it together towards the services we provide? And I think that's actually a very great question to ask at HY, because besides microgrid, which I talked about, and digital twins, there is one more area that we are building up that's important in any of this conversation, and that is actually cybersecurity. We talk about digital systems, we talk about microgrids, all of it has some form of smarts. The moment I use the word smart, automatically you need some form of cloud or some form of digitalization. And once that occurs, you become vulnerable to cyber attacks, especially since digital twins and microgrids are meant to control where energy flows and what happens in the system, right? I don't think everyone doesn't want a situation where a remote hacker can gain control of your system and start controlling it, which is worse. So one of the new areas that we've included this year is cybersecurity by design architecture. So if we were designing a microgrid system for a client, we will make sure that the architecture of the system already incorporates a cybersecurity consideration by design, not just adding a top, because cybersecurity is something you cannot just, like put paint on the wall and say, oh, the cracks are made over. No, there's still a crack. You need to incorporate it from the beginning already. And so this is something that's very important that we also provide in our services going forward. And on the broad scale, be it for solar, be it for nuclear, especially for nuclear, this cybersecurity component ties everything together. In the case of a solar farm, if you use a microgrid controller and someone gains access to the microgrid controller through whatever means, they can actually divert the flow of electricity to the grid and overload the grid, causing destabilization, right? Because the idea is that if there's too much sun, I can just power too much energy to the grid, and you actually destabilize the grid. Now imagine if this is a nuclear reactor where the power is constant and then it's at night, there's not much power, and you have a controller that can be accessed by a remote attacker somewhere else on Earth. The person knows there's a nuclear plant, they can just divert the electricity either back to the plant and blow up the turbine or destabilize the grid. Now, to all the viewers of this podcast, I can assure you that the reactor core will be safe because the cores are designed to not be digitalized. They're meant to have passive safety and all whatnot. But think about the optics. I don't think anyone would like to hear the fact that the power plant at the nuclear power plant exploded, regardless of whether the reactor is safe. So it's about ensuring the optics of the situation also is correct. You do all that is necessary to protect your digital systems from a remote attacker or remote access or whatever cyber attack that can occur, because there are real physical consequences this time to cyber attacks. This is not like a data breach where someone steals your name. There are actual physical consequences. So in recent years, I'm seeing the term cyber physical risk because the cyber attack has resulted in a physical risk. And
very interesting.
Indeed. So that's why this area is how we tie everything together for our consultancy for power grids in terms of solar farms, hydrogen, battery storage, and even nuclear.
Interesting, fantastic. That's a new phrase to me, cyber physical risk. So between the three main services and three main sectors that you've just described, yes, how would you say you and your team is contributing towards the development of AI infrastructure, decarbonization, or energy security?
Well, I would say that the way that we provide our services is firstly by enabling new data centers to be built, taking into account energy needs and a secure energy supply, right? Then at the same time, as I mentioned, cybersecurity becomes a very important consideration. So we ensure that whatever power system or digital twin system that we design for people is already is as secure as possible from external threats, right? As I do want to highlight to our listeners, cybersecurity, there's no such thing as 100% secure. The best way to have 100% secure is no system. But what you can do is you can mitigate the risks as much as possible, and also design the architecture in a way such that even if someone breaches one area, it is not a whole system compromise. And that's very important to enable AI infrastructure. At the same time, we talk about decarbonization. Well, we and our digital twins, our microgrids enable, as I said, a smart energy ecosystem that enables your applications in the built environment to use less energy or lower your carbon footprint. That is actually very important because the built environment can actually consume a lot of energy. And this built environment also includes your manufacturing plants and whatnot. So you want to make sure that all your applications are consuming as optimized as much possible energy. You don't want to be over consuming. So the next best thing, of course, is optimize your consumption, right? Keep it as low as possible and make sure that when you keep it as low as possible, also take into account human comfort. I can give you a direct example. In Singapore, we are using Go 25, meaning set all your temperature at 25 degrees to optimize for the environment. The concept is great. I want to make it very clear. I have no issue with the concept. But when a day like today in Singapore, it's raining, the humidity goes high at 25. So what we are discovering in HY is that when you talk about maintaining energy, you also need to maintain user comfort through multi-factor optimization. So again, because we're using digital twins for this multi-factor optimization, all of a sudden we are also enabling decarbonization of the built environment even better while ensuring the people inside it have a good user experience and not complain about the fact that we're trying to save the environment, but everyone else feels uncomfortable in the process. So these are the few ways we do it. Yeah.
Very, very helpful insight there. Now, naturally, this podcast is about the journey of financing. Now, how does financing become more bankable, so to say, when you've got knowledge from a technical perspective? What is it that you're offering that allows investors or lenders to feel comfortable with these somewhat new sectors?
Certainly, it's a very relevant question in the world that we see today. There's been a lot of push, right, to decarbonize, and all of it needs money. And that's very important. I mean, as much as we all want, as you and I want to save the planet and make it green, we need to make sure we're not throwing money and never seeing good returns, because that's how the system operates. And so companies like HY become a very good partner for your VCs, for your banks, for technical due diligence. If someone comes to you and says, hey, I want to invest in this solar farm to power XYZ, one of the most important things that you need as a bank or a financier, you need to know is this thing designed credibly? Is it going to short out on me all of a sudden and lose my investment? And also at the same time, we talk about insurance premiums, right? All this comes into the picture. So you will need to engage someone like HY or a similar company to go through the design, make sure that you've designed everything as practical as possible, as correct as possible, using best practices and up to codes. Then if you have a third party certifying it, again, in Singapore, we have this phrase, right? Own self, check own self. That can't be the case when you ask for money.
Say that phrase again.
Own self, check own self. Basically, it means I, Matthew, claim that Matthew's work is fine. That makes zero sense at all to people.
Right. Grading your own homework effectively.
Exactly, and the banks will clearly not take it, and I don't blame them. So you need a third party like HY to look at the design and go, okay, our professional engineers, our licensed electrical workers, our engineers have taken a look at it. Nothing here seems out of the ordinary. It follows international standards or even beats international standards, depending on how zealous the person is. It is safe by our standards. Here are the risks that we've identified and they've been mitigated. And imagine if you are an insurance premium provider, you will feel safer to provide a lower premium because these people have done their homework. If you were a bank, you will give them low interest because the risk is lower. And all this comes into the picture. So companies like HY that provide this service, important. And it builds upon the fact that we are designers ourselves. We are here to be a verifier as a third party for companies that need that third party. And as you say, due diligence, okay, it's been done, it looks good. That's all that needs to be said.
Brilliant, fantastic. And I think this is a repeated message that I'm increasingly promoting and hearing being discussed, that the financiers and the technical community need to start speaking with each other, because there are benefits to understanding each other's businesses and taking it back to make sounder investment decisions, isn't it? And if you had to sum up your thoughts on where we are today and where the near future is for AI infrastructure, decarbonization, or energy security, where do you see that currently and in the near, say, 5 years' time?
I would say that in the world of AI, I would say that there's a lot of hype. And it's great that there's hype. Hype means that there's a catalyst to grow. But at the same time, there's also a need for many engineers, infrastructure engineers, your electrical engineers, your mechanical, your nuclear, civil. All this is required to enable this AI future. AI is great and all, but if you don't have the engineers to design the buildings, design the networks, design the racks and the cooling systems for these data centers, AI is nothing, right? You can have 10 million software engineers and AI architects, AI engineers all around the globe, but if no one's building these data centers or this infrastructure, it is for naught. So right now, I see a lot of interest, which is great, but we also need a lot more of your traditional engineering that I just mentioned about to also grow. And one way to do that, as I would like to highlight to anyone who listens, is finding your core, finding your calling. Engineering is meant to be a career of meaning, where you are the engine of development, the engine of change, the enabler of evolving. It is with engineering that all this evolution is enabled, right? And so don't see, and for people who are wondering what career they want, don't see engineering as just, oh, it's a workshop and I'm hammering tools. No, you are actually the engine of development. Many of the things that we see in today's world happen because engineers made them happen. And so that's what we need the people to do. And how I would sum up the world, how I would sum it up is there needs to be a lot more interest also in your traditional engineering to enable all this AI. And that is something I hope to see. I do think people are aware of it, but now let's make that a reality in the next 5 years.
Brilliant, Matthew. I think you are the flagship and a beacon for the engine of development. It's been really insightful hearing from you, Matthew. Tell us how we can hear more about you, about your company. How can someone who's interested in you get in contact?
Oh, for sure. I mean, the most direct way, of course, is contact me via my email, via my WhatsApp. You can find me on LinkedIn. You can just search for Matthew D. Chew. The D is one of my middle names, Dominic. There's another story why I only put D, but just for the listeners, it's got nothing to do with the anime. There's another reason behind it, but
give us that reason.
Yeah. The reason is because my middle name Dominic at one point was not long in Singapore. When we were writing our full name, it couldn't fit my name Dominic, so I had to put D. So for the longest time, I just kept writing Matthew D. Chew because it was cool. It just so happens that in the world of anime, there's also one piece where they call people D Clan, and people think it's because of that. No, it is not. It's literally because at one point my name couldn't fit onto the application forms because it's too long. Of course, at the same time, you can search for HY's website. So the website we have is hy-me.com.sg, or you search for HY on LinkedIn, where it's just HY. Please note there's a HY in the US, so choose the right one. We're in Singapore, not in US.
It's been really insightful hearing from you, Matthew. Thank you so much for your time. Thank you for sharing your insight. And we look forward to hearing more from you and how you contribute to this growing sector of technical engineering.
Thank you very much, Doreen, for having me.
Brilliant. Fantastic. Thank you. Thank you for listening to Bankable. For early access to energy transition pioneers and to learn how to structure the investment solutions described in this episode and throughout the series, subscribe to the podcast and get in contact at frescocleantech.solutions.